Uh, is my writing readable? Are you able to read it? Like, okay. The first one is the group one. The name is alkaline metals. Okay. How can you differentiate metals and non-metals? Just give me like general physical differences. Like, good, good. And non-metals cannot. So why do you think that metals can conduct? Why? What makes them good conductor? You don't know? Okay, do you have any idea about the bonding? Any idea about the bonding? Yeah, because of the electrons that are freely moving, uh, that are far, oh sorry, that are delocalized. Okay, so this makes it like good conductor. So all the metals they have delocalized electrons which freely move in the sheet or the elements or elemental substance. Okay, what type of ions are formed by the metals? Let's say metals are conductor because they have freely moving electron. Okay, okay. What type of ions do these elements form? Positive one or negative one? Positive ions. Because we are going to use these properties further on. Okay, let's talk about, because now we have to relate this to their chemical properties. So when we move down the group from lithium to the francium, their reactivity increases. Now, why does it increase? As we have discussed, that they form positive ions. So, the ease with which electron is lost makes it more reactive. If it's easy to lose electron, it would be reactive. If it is difficult to lose electron, it won't be reactive. Okay? Let me give you an example. For example, there is a bigger class. There are so many rows. The last students can leave easily. The teacher cannot have the control on the student sitting in the 10th row as compared to those who are sitting in the first row, right? So a bigger size mean there would be less control on the on the outer shell or on the outer electrons. So those electrons can be lost easily. That's why a bigger size mean more reactivity. So down the group, because the shell number is increasing, we are saying there are more number of rows now. So more rows mean a bigger size. Bigger size mean there is less control on the outermost shell or on the outermost electrons, so they can be lost easily. That's why francium or cesium is more reactive as compared to lithium. Okay? All right? Okay, let's talk about their like reactivity. Let's write the reason. What is the reason behind it? Ease to lose electron. It depends on ease to lose electron. So bigger size or the element with more shells can lose electron more easily or more readily. Okay, so the reactivity increases. Clear? Is this point clear to you? Okay, the second thing is the melting or boiling point. So what do you think? What is the like, what would be effect on the melting point or boiling point? The melting point would increase. melting and boiling point would decrease. Okay, it would be opposite to reactivity, let's say. It would be opposite to reactivity. The melting and boiling point would decrease. Okay, and why is this so? Because we have said that the reactivity increases. Let's say, let's add lithium to water. Okay, it can react with hot water, means we have to give it some energy so that lithium can be activated and it forms lithium hydroxide. Sorry, there is no bracket over here. Okay, now this reaction has a little frizz, like it fizzes but it is not that much high, a little frizz. Okay, but when we put sodium into water, there would be a frizz and there would be a spark. You can feel a spark of sodium. So there are certain like tests in which we use sodium to test to identify certain organic substances. So when we add sodium to water, it form like hydroxide, definitely sodium hydroxide, and you can see this a little spark. So you can see it can fizz quickly with a little spark. You can actually feel fire in the water. Okay, but when we move more like further on to potassium, when this potassium reacts with water, there would be more spark. You can feel the spark. The reaction would be a little bit explosive, not to that much, but it's a little bit explosive, and its color would be, or you can say its color would be lilac, like a light purple shade. Are you getting my point? Okay, let's write a spark and a lilac color. Okay, now as we move down the group, the reaction with cesium or francium would be really, really explosive. Okay, the reaction if we put these elements in water, they can even react with very cold water. Now look over here, I have written lithium with hot water, but this potassium has an ability to react even with cold water. It's that much reactive. Okay, but before starting this, let me tell you something. Now with temperature, the chemical reactivity generally increases because when the temperature is high, kinetic energy is high. The molecules have the more effective collision. They collide and they do a reaction. Okay, that is a general overview in chemistry. It's not true for all the elements, definitely, but it's a general overview that when the temperature is high, kinetic energy is high, so most of the time effective collision is higher, due to which the reaction become easy. But when the thing is cold, when the temperature is low, the reactivity is low because the kinetic energy is low. That we generally believe. So potassium can even react with cold water and can produce sparks or a greater fizz or explosive like explosion reaction. Okay. Um, what else we need to discuss? Okay, we have discussed this. Okay, let's talk about the general. We have talked about the general reactivity, that due to bigger size, the elements with more shells can lose electron more easily. Now, let's talk about the chemistry behind it. This is a general example that I've given you. Okay, now what is the chemistry behind it? So let's say there are like 10 rows. 10 rows means there are some inner rows which act as a shielding effect. This is called as shielding effect. The inner electrons, or the in between one, the shells, in between shells, the middle shells, they act as a hindrance that the nucleus cannot have a control on the outermost shell. This is called as shielding effect. No? Didn't get it? Okay. So, if we have two rows, if we have two rows, there are like lesser number of hindrances between the nucleus and the outermost shell. Okay? If there are six shells, there would be hindrance in between the nucleus and the outer shell, right? Sorry? Hindrance mean obstacle, blockage, blockage. Let's say blockage. Okay. So if nucleus is over here and there is first row, then second, then third, then fourth, then fifth, and then sixth. So these one act as a shield, they act or they produce shielding effect, which actually blocks the nuclear attraction to the outer shell. Okay, so the middle one shells, they act as a blockage. So when the size increases, or when the atom is bigger, or it has more number of shells, then the shielding effect would be really high. More number of shells mean more shielding effect. So more shielding effect means there would be it would be easy to lose electron. Okay, and losing electron means greater reactivity in metals. Okay, let me just make this back. I'll share these notes with you as well, so that you can make your own notes. Okay, but you have to make your own notes as well. It's really important. Okay, let's move to the next group, group number 7. um, Group number 7. So what is the general name that we have given to group number 7? Halogens. Okay. Now metals and non-metals are opposite, acts oppositely to each other. Let me change the color to differentiate it. Just give me let's use this. Okay. Group 7 is halogens. They are opposite to metals. Metals form positive ions, they make negative ions. Okay? Okay. So they usually produce acids when they react with water. Like, you must have heard of hydrochloric acid. Okay. So this is the one which make acids. Okay. Because they accept electrons, now the trend would be opposite. Moving down the group would decrease the reactivity. I'll tell you the reason. Just give me a minute. Okay. So there is a bigger class. Let's take an example. There is a bigger class. Okay. A new student wants to enter in. Now there is space over here that new students sit over here. Okay. Can this student develop a bond with this teacher? Would it be easy for this electron to make bond with teacher? No, because it's really far away. So when the size of non-metal is quite big, it becomes difficult to accept the outer electron. Okay, but if the size is small, like it has only two electrons or two shells, so if electrons sit over here, it is easy to develop bond with the nucleus, right? So the same would be applicable to atoms. If the electron enters the shell, which is nearer to the nucleus, it can develop some nuclear attraction. But if it's quite far away, it cannot develop nuclear attraction, due to which the reactivity decreases. Okay. Okay. So let's talk about the periodic table. What do you think? Which has the highest reactivity and which has the lowest reactivity? Look at the periodic table. Yeah, in the periodic table. Let's talk about only four of them: fluorine, chlorine, bromine, and iodine. Let me write this. Fluorine. Okay, fluorine has the highest reactivity. Then is a general trend. So there is one property which is quite important in chemistry, which is called as displacement. Because fluorine is more powerful, it has more nuclear attraction for any of the other atom due to smaller, because it's smaller in size, its nucleus has more attraction for other elements. It can displace chlorine, chlorine can displace bromine, bromine can displace iodine. But iodine cannot replace bromine, bromine cannot replace chlorine, and chlorine cannot replace fluorine. Shall we do some examples for this? Let's write NaBr plus F₂. Okay, one more thing. These are diatomic elements. Like they exist as F₂, Cl₂, Br₂, and I₂, if they're individuals. Halogens are diatomic in general elements like F₂, Cl₂, I₂, and Br₂. But when they make bond with other one, there can be one atom. But when they exist independently, like oxygen, oxygen is always O2. If they exist independently, they are diatomic. This is how we write it. Okay. Can this reaction be possible? Can this reaction be possible? Why? What? Because this fluorine is more powerful, smaller in size than bromine, right? So it can replace bromine. Okay. Can this reaction be possible? Not possible. Good. Why? Because chlorine is less powerful to replace fluorine. Okay? Okay. So you get this thing. Um, let's talk about their melting and boiling point. What would be trend? If their reactivity decreases down the group, what would be trend of melting and boiling point? They decreases. Oh, sorry, increases. Increasing. They increases down the group. Okay, there is one more reason that why their melting and boiling point increases down the group. Because of their physical state. Now this is the element where the physical, this is the table or this is the group where the physical state of element is different. Let's talk about fluorine. Fluorine is a gas, while chlorine, let me write the spelling because you focus more on spelling. It's a gas again, generally. Otherwise, chlorine is also available as liquid chlorine. Bromine is basically a liquid, while iodine is a solid. Okay? So solids usually have higher melting and boiling point as compared to the gases. Gases. Okay, this one is basically greenish in color. Very pale green. This one is yellow green in color. This is brownish in color. This one is purple in color. But when we move down to astatine, because there was one question related to it, that you have to deduce the astatine, the properties of astatine. What is the solid state and what could be its color? So what do you think? What could be the physical state of astatine and what could be its color? It would be solid. And what could be color? As the color is getting darker and darker. Black. Good. this is how we uh, predict the properties of the periodic table. Okay. Okay. So um, we have discussed the physical properties, the boiling point, and we have discussed the chemical property that the reactivity decreases down the group. Okay. Let me give you few points. Oh, sorry. Because we need to write this when we talk about the reactivity. Okay, you need to tell me, or you need to explain me these points, because later on I'll explain. Okay. The halogen react by gaining an electron in the outer electron. So as you go down the group, the reactivity decreases. That we learned already. So what is the reason? The outer shell become further from the nucleus or away from the nucleus. There would be more shielding effect. Attraction between the nucleus and outer electron would decrease, due to which it becomes less reactive. Okay? We have already discussed this reason, right? We discussed, but we haven't written this one. Okay, let's move to the next group. Um, that is the first of all, let's talk about the general gases. Okay, what what gases do you think are present in our atmosphere? Oxygen, carbon dioxide. So these are the two major one that we usually discuss. Okay, what makes the most part of the atmosphere? Nitrogen. Okay, let's talk about the gases. Atmosphere. Nitrogen is present in the highest quantity or highest percentage. What's the percentage of this one? 78%. Your voice is really low. I couldn't hear you clearly. Okay, second one is oxygen. What's the percentage of oxygen? That is around that is around 21%. Then there is an inert gas, a noble gas, argon. This one is around 0.9 to 1%. And then the increased carbon dioxide in the atmosphere, which is 0.04% now. So previously we used to have the 0.03%. Normally we discuss that, but now the percentage has increased a lot. It's 0.04% now. Okay. Um, what do you think? What's increasing the carbon dioxide percentage in the environment? What are the different factors? Greenhouse gases. Okay, what it's a greenhouse gas, carbon dioxide. What produces this gas? The burning of fossil fuels. Okay, so let's discuss greenhouse gases or greenhouse effect. Okay, due to burning fossil fuels. Okay, what else can be the reason for the greenhouse gas? We have discussed carbon dioxide. There is one more other important one, which is methane. Any idea the what is the source of methane in our atmosphere? No? Okay, the marshy places which have the stagnant water most of the time, or the paddles, the rice fields, they produce lots of methane. Okay? Do you know that? Do you have any idea that rice needs a lots of water to grow? So it's a marshy place basically. Marshy place where the water stays for a longer time. So these produces the methane gases. Okay, so what is greenhouse effect? I want to hear from you. It's okay. You can explain whatever you know. Okay. W- And how, what do you think, how these are, like, how these negative effects affect it? Look, or what creates that negative effect? What, okay, the global warming. Okay. Um, let's have a more deeper understanding of this. Okay. Generally, generally, during the day, if you observe it, the light enters the atmosphere with the time passage of time. This light is converted into heat. That light is absorbed by our earth, that converts light into heat. Okay, that's a general reaction of our, that, or just that's the, this is the general response by our earth. Okay, now that heat needs to be exert from the environment. Okay, that is a general process. But what happened due to the greenhouses gases? The heat cannot escape out because of its bigger wavelength. Okay, do you have any idea about the wavelength? No. Okay, let's discuss the wavelength then, first of all. Hmm, different different lights, like UV radiations or the IR radiations or the light, visible light, they have different wavelength, like this or this. Okay, some have a shorter wavelength, some have a longer wavelength. So when we compare heat and light, light has the shorter wavelength and heat has the longer wavelength. Okay, this is the general thing that we know. So what will happen, that when this heat wants to escape, which is a bigger wavelength, it cannot escape out, being bigger in size, let's say, due to which heat is trapped inside the earth atmosphere or the that blanket, and because of this the temperature of earth is increasing. Okay, this is this is the whole thing, that what is greenhouse effect. Can you explain it now? Okay, let me ask questions. What are the three major greenhouse gases? Two have written images. Okay, okay. Third one is water vapors. Yeah. Okay. Now, what actually happened? Yeah, what actually happened? Why why the temperature is increasing? Okay. Okay. Good. Okay. I'm giving you one diagram for a better understanding. Or you may also or already have seen this diagram. So these sun rays, they have the shorter wavelength. Okay. So these are absorbed by the Earth's surface and converted into a longer wavelength, that is heat. Okay, which needs to be emitted out. But due to greenhouse gases, this heat is trapped, due to which the Earth is becoming hotter. Okay, got it now? It's a simple thing. Okay. So sorry, I will ask you about the um sources of carbon dioxide, and we have discussed only one, which is the burning of fossil fuel. Let's write the other one as well. What else is the major cause of this carbon dioxide in atmosphere? Burning fossil fuel, respiration, respiration by animals and plants both. We respire out carbon dioxide. Okay, there is one more, which is the thermal decomposition. Remember, we have discussed the thermal decomposition in our demo lesson. The thermal decomposition of calcium carbonate, which breaks down the calcium carbonate into calcium oxide and carbon dioxide. Okay, so thermal decomposition means heat converts some carbonate compounds, carbonate means CO3 compounds, into carbon dioxide one. So it releases carbon dioxide, and we studied over there as well that carbon dioxide increases the temperature, right? We discussed already. Okay, so this is the general thing. Okay, the next thing is the how do we determine the percentage of oxygen in the atmosphere? Have you done that experiment already? No, you didn't. Then we'll do it later when we do the testing ones. Like how do we test different things? Okay, because it needs like more time. Okay, thermal decomposition. Let's talk about thermal decomposition then. So as I have defined, what is thermal decomposition? Exactly. Carbon dioxide. Good. So let's talk about the thermal decomposition. Um, I'm giving you. Oh shit. Sorry, I made a mistake. Just give me a minute. I was about to copy it, but I wasn't copying properly. Okay. Just go through this. What is written? Just go through it once, and if you couldn't understand it, you can ask. Okay. Carbon is mostly because we are like relating it to the production of carbon dioxide. Okay. Shall I give you an equation, and would you be able to tell me what is the product then, or what is the product of the thermal decomposition? Let me write. Metal carbonate. Let's take an example. Copper carbonate. I have already given you this example. Copper carbonate gives copper oxide. Oh, I've given you the calcium one. Sorry, and carbon dioxide. Let's write calcium carbonate. What are the products? Sorry, what's the product? Carbon dioxide and what metal oxide is formed? Calcium carbonate, calcium oxide. Okay. Um, how do you test carbon dioxide? Now that this one is a simple test. How do you test carbon dioxide? Not sure? Okay, we use lime water. The lime water is basically a transparent material. When the carbon dioxide is added to it, it turns milky. Okay, there will be change in the clearance. It becomes a bit turbid or a cloudy. Sorry. Okay, let's talk about another reaction, which is combustion. So oxygen is one of the other gas. We have discussed carbon dioxide. Let's discuss oxygen. Oxygen. So there is anything that uses oxygen is basically combustion. Carbon burns in oxygen or coal. Carbon is basically coal, let's say. Coal burns in oxygen and produces carbon dioxide. So this is combustion. Okay, let me write something. Magnesium plus oxygen. What does it produce? Have you ever seen the reaction or the burning of magnesium ribbon? No? Okay, it's available in market, by the way, the magnesium ribbon. And when you burn it, it produces a certain type of flame, and it's like burn with a spark. It's a white flame. And as a result, when you burn that ribbon, it would definitely, it turns into like powder, just like a paper. Like the paper turn into like ashes, it turns into powder. Mm, i Basically, some of the crackers use these, the firecrackers use magnesium as a source. Okay, yes. There are different type of firecrackers, right? Okay, hydrogen. What will happen when hydrogen burns in oxygen? Let me write so that you'll be able to understand. What will happen when hydrogen burn in oxygen? What would be the product? Think again, think again. It's very simple. H2O. Okay. If a sulfur or nitrogen burns in oxygen, oxide. Yes. Okay. So if you look closely, the temperature increases on all of these reactions, right? So we say because the temperature increases, the energy is given out. Not the temperature increases, basically the energy is given out. Because energy is given out, we call these reaction as exothermic. Okay? So these are exothermic reactions. How to define exothermic reactions?